The James Webb Space Telescope offers astronomers an unprecedented view of the cosmos, revealing intriguing discoveries that continue to captivate the scientific community. Recently, researchers directed the Webb telescope towards a remarkable grouping of 5,000 relatively young galaxies, among which they found the youngest galaxy to date, uncovering a series of extraordinary cosmic phenomena that have left scientists perplexed about their possibility. This situation is advantageous for both science and humanity. The initial data released from the SEERS research presents a region known as the extended growth strip, taking us back to a time just after the Big Bang. In this video, more than 5,000 galaxies can be seen in vibrant colors and in 3 dimensions. The cosmic journey starts with relatively nearby galaxies located billions of light-years away from Earth and ends with Galaxy Mazy, which is 13.4 billion light-years away from Earth and is one of the farthest galaxies ever observed by humanity. It is seen as it was approximately 390 million years after the Big Bang. Thus, this new Webb telescope video not only represents a journey through space but also a trip back in time, retracing cosmic evolution to a period when the 13.8 billion-year-old universe was only a third of its current age. The video is a result of data collected by the Preliminary Scientific Research SEERS, which explores a region of space called the Extended Growth Strip. This strip is located between the Ursa Major and Bovis constellations and contains about 100,000 galaxies of particular interest to astronomers. In this visualization, Galaxy Mazy serves as an example of the kind of young galaxy that JWST can study. Additionally, astronomers, using the telescope, observed a sequence of ancient galaxies stretching over more than 3 million light-years, connected by a cosmic filament dating back to the early days of the universe. This ancient filament of gas and stars may represent the oldest known structure of the cosmic web, and this discovery can help elucidate how the universe was formed and the invisible connections that hold it together. This filament is anchored by an extremely bright celestial object with a supermassive black hole known as a quasar at its center. Over the past 20 years, research has revealed that the universe is built like a support structure, with a series of invisible filaments and clusters. These clusters are composed of dark matter and highly dense regular matter, creating the ideal conditions for the birth of stars and galaxies. Between these clusters and filaments, there are regions of low density in the universe, where there are few galaxies and less matter. Although the filament itself is invisible, it can be observed as it links the galaxies together. Meanwhile, a quasar, a luminous supermassive black hole, is considered the anchor of the filament. The team believes that, eventually, galaxies will be pulled together to form a cluster, much like the nearby Coma Galaxy cluster. The team also hopes that the discovery will bring more information about the cosmic web but is also very interested in how quasars formed in the early stages of the universe. Speaking of quasars, astronomers using the James Webb Space Telescope have detected the most distant actively feeding supermassive black hole ever observed. This black hole is also one of the least massive ever seen in the primordial universe, with the equivalent of about 9 million times the mass of the Sun, which has been challenging to explain. The researchers observed the galaxy housing this active supermassive black hole as part of the preliminary research into cosmic evolution, called SEERS 1019. The galaxy is seen as it was when the 13.8 billion-year-old universe was only about 570 million years old. This is because the processes by which supermassive black holes grow, either through mergers of successively larger black holes or through the voracious consumption of surrounding matter, should have taken longer than the 570 million years this black hole had to work with. This means that even black holes the size of the one at the center of the Milky Way, which is about 4.5 million times the mass of the Sun, should only be seen in the relatively nearby and thus more recent universe. The black hole at the center of SEERS 1019 has about 9 million solar masses. This may seem tremendously massive, but many supermassive black holes can grow to have billions of times the mass of our star. However, even with this relatively smaller size, the existence of such massive black holes in the primordial universe is still a puzzle for scientists. Observing this distant object with this telescope is very similar to observing data from black holes that exist in galaxies close to us. Scientists have long suspected that such supermassive black holes existed in the primordial universe, but it was only since the JWST opened its infrared eye to the cosmos in mid-2022 that definitive proof emerged. The light emissions reveal that the Sears 1019 black hole is actively feeding on the surrounding matter. Black holes feeding like this are surrounded by swirling gas and dust falling towards them, known as accretion disks. Besides gravitationally influencing this matter, causing the disk to shine brightly, powerful magnetic fields channel the matter to the black hole's poles, where it is occasionally ejected in twin jets moving nearly at the speed of light, generating intensely bright light. Observing the intense radiation from the black hole can reveal how rapidly its host galaxy is growing and possibly provide information about its mysterious past. Galaxy mergers may be partly responsible for fueling activity in the black hole of this galaxy, which may also lead to an increase in star formation. Whatever the case may be, scientists are analyzing the data precisely. These data revealed by Webb have drastically changed the way we look at the primordial universe, with galaxies forming only about 390 million years after the Big Bang, which in itself is a challenge to our cosmological model. Of course, we can adjust the model based on the revelations made by the telescope, but there is much more to be discovered from the countless information collected by Webb in the primordial universe. Scientists have also suggested that, although Galaxy Mazy is the youngest galaxy so far, additional observations point to even younger galaxies and black holes adorning the baby universe. Therefore, going back to the drawing board will not only be necessary but absolutely essential. Whatever the universe is hiding from us is just a matter of time. Soon, we will have the answers, or, rather, we will know where we can find them. As I said, this is advantageous for both science and humanity. What is your opinion? Leave it in the comments below, and don't forget to subscribe to Nebula Mind. Thank you.